So chapter 5 of MYP4 unit 1 is called the quadratic formula. So we've seen some quadratic equations, x squared plus 6x plus 8 equals 0, x squared plus 20x plus 96 equals 0, 3x squared plus 5x plus 2 equals 0. They all have a particular form to them, and that's some number x squared plus some number x plus some number on the end equals 0. So the general standard quadratic equation has this form: ax squared plus bx plus c equals 0, where a, b and c are some particular numbers that we're told in relation to the particular equation that we've got to solve. Now, that can be rearranged. We'll look later in the unit at how, but we'll just take it as read for the moment. That can be rearranged as x equals minus b plus or minus square root b squared minus 4ac all over 2a. So those two things, the thing in the red box and the thing in the yellow box, are basically the same thing. One is just a rearrangement of the other, but the one in the yellow box is useful because it tells you what x is. So you just need to plug in the numbers that are in front of x squared and x and the number on the end, the a, b and c, and you get the solution. You get what x is that solves the equation. So it gives us a formula for finding x. So here's an example. Solve x squared plus 18x plus 72 equals 0. So we've got just a single x squared there, so that's like having 1x squared. So a is 1. We've got 18x, so b is 18, because it's how many x's we've got. And then we've got plus 72 on the end, so c equals 72. So I take that formula, x equals minus b plus or minus square root b squared minus 4ac all over 2a, and I plug in all of those numbers. Now you've got to be very careful with minuses here. So I've got minus 18 plus or minus the square root of, and then that square root is around a big thing that says 18 squared minus 4 times 1 times 72, 4ac, all divided by 2a, so all divided by 2 times 1. So I tidy that up a bit. 18 squared is 324, 4 times 1 times 72 is 288, so I get minus 18 plus or minus the square root of 324 minus 288 all over 2, and that boils down to minus 18 plus or minus 36 over 2. Remember, a square root can be plus or minus because, for example, 6 times 6 gives you 36, but also minus 6 times minus 6 gives you 36. So the square root of a number can be a positive or a negative value. And that's what gives us two answers when we get two answers to these. So we get x is minus 18 plus or minus 6, all divided by 2. And then I've broken that down into the two possibilities. So x is minus 18 plus 6 divided by 2, or minus 18 minus 6 divided by 2. So two different answers for the bit that says plus or minus. And then if you carry on with that, you get minus 6 or 12. So the solution to that is x is minus 6 or 12. So here's another, here's a set of questions for you to try. Please pause screen, have a go at them. Okay, so first one, x squared minus 7x, x squared plus 7x minus 44 equals 0. So we've got just a single x squared, so 1x squared, a equals 1. We've got 7 x's, so b equals 7. And then we've got minus 44 on the end, so c is minus 44. We've got to be really careful with those minuses. So minus b plus or minus square root b squared minus 4ac all over 2a becomes x equals minus 7 plus or minus the square root of, and then that square root is all around 7 squared minus 4 times 1 times minus 44. This is where people trip up with all of these minuses, because, and all of that divided by 2 times 1, by the way. Yeah, so people trip up on the minuses because then on the next line you get minus 7 plus or minus the square root of the 7 squared. 7 times 7 gives us 49. Then we've got the minus that was in the formula to start with, but then c was a minus number, so we get another minus there from 4 times 1 times minus 44. So within the square root you get 49 minus 176, and the two minuses together make a plus, so that's the same as 49 plus 176. So on the next line you get minus 17 plus or minus the square root of 225, 49 plus 176, all of that divided by 2. So lots of ways you can trip up trying to keep track of the algebra here. Keeping track of the minuses, and then remembering that when you've got a fraction, it's basically like there's a big bracket around the whole of the top and a big bracket around the whole of the bottom. So you've got to work out the whole of the top and the whole of the bottom before you start dividing things. This being an exam type example question, that square root is an exact number. That boils down to minus 7 plus or minus 15 over 2, 15 being the square root of 225. And then that plus or minus gives you the two answers, so minus 7 plus 15 over 2, or minus 7 minus 15 over 2, x equals 4 or minus 11. Okay, next one, x squared minus 6x plus 9 equals 0. So a is 1 because we've got 1x squared, single x squared. B is minus 6 because we've got minus 6x there. Whenever you see a minus, it belongs to the number that comes next. And C is the odd 9 that we've got on the end. So we stick all of those into the formula, being careful with minuses. So like at the start we get a minus 6 because there's a minus in the formula that B was already a minus number. And you've got to be careful with minus 6 squared because minus times minus makes plus. So when you do minus 6 squared, it will be plus 36. And on this particular one, the square root bit turns out to be 0. So you get 6 plus or minus 0, all divided by 2. So what happens there then is because it's plus or minus 0, you only get one answer because 6 plus 0 and 6 minus 0 is just 6. So you only get one answer, 6 divided by 2, which is 3. So in this case, x only has one possible solution, 3. And we've seen previously with other ways of doing quadratics that it's quite possible for a quadratic to only have one possible solution. Okay, question 3. We got 3x squared plus 2x minus 8 equals 0. So A is 3 because we got 3x squared, B is 2 because we got 2x, and C is minus 8 because we've got minus 8 on the end, and whenever you see a minus, it belongs to the number that comes next. So sticking that all in the formula, we get minus 2 plus or minus the square root of 2 squared minus 4 times 3 times minus 8, all divided by 2 times 3. So you've got a minus in the formula and a minus 8 there, so you're going to end up with a minus within the square root. So in that square root, you get 4 minus 96, which makes the same as 4 plus 96. So you end up with the square root of 100 in that one. So you've got to be careful with the minus there. If you didn't get the answer shown here, that's where you're most likely to trip up. And as it turns out, this one boils down to have a fractional answer. So minus 2 plus or minus 10, all divided by 6, gives you x equals minus 2 plus 10 all over 6, or minus 2 minus 10 all over 6, which is 1 1/3 or minus 2. And then I did a little note in with GeoGebra. We've seen that some quadratics don't have solutions or roots, since their graphs never across the x-axis. So what happens with one of those when we try to use the formula for it? X squared plus 3x plus 8 equals 0 is such an example. If you try and do the graph of y equals x squared plus 3x plus 8, you find the graph never crosses the x-axis, so it doesn't have any real solutions. But surely we can put the numbers 1, 3 and 8 into the formula. So what happens when we try and put those numbers into the formula? And what happens is we try and do it and we get the square root of a minus number coming out in the formula. And we can't do the square root of minus 21 yet. I say yet because I already talked about, I already alluded to something you're going to do in the future where you're allowed to have the square root of negative numbers, but it's not within the remit of this unit. And that value in the formula, b squared minus 4ac, the bit that's in the square root, is known as the determinant. And whether it's negative or not will determine whether an equation can be solved. So if b squared minus 4ac is less than 0, then you'll end up getting the square root of a negative number and the thing won't have any solutions. So then we did some exercises from the book, page 364, question 2, A to L, which I asked you to solve using the formula, irrespective of any other instructions about how to do it in the book. Went through a few examples in class. So, yeah, there's one. Pause screen if you want to look at any of these. A little bit roughly drawn, but there you go.